Hello and welcome to Gaffy's Grinds. In this channel we take difficult concepts from junior cycle science, we break them down, try and explain them as simply as possible, give you some practice to do to make sure you master the content. While you're watching these videos, you should close any open tabs you've got that aren't necessary, especially any social media tabs, which are just going to distract you. And I'm going to give you some tasks and questions to do during the video. You should make sure you do them. If you don't do the questions, you're not going to learn very much. One more thing is you should really listen while I'm explaining, not try and write everything down. If there's something you really need to write down, I will tell you. This is the first video in a series on energy. Now, energy is one of the most difficult concepts to teach because it's very difficult to describe simply what energy is. It's so difficult that some textbooks don't even try to do it. So what I'm going to do is I'm going to try and explain it as simply as I can using very straightforward, simple definitions. There are two main terms when it comes to energy that we're going to be talking about during this topic. And those two terms are energy stores and energy transfers. Now, this video is going to be about energy stores. So what is an energy store? Well, if you take an object and you look at everything that's happening around an object, whenever something happens to an object, so say its temperature increases or its temperature decreases, it falls over, you throw it in the air, it catches fire, it makes a noise. What else? Literally anything. If you do anything to an object, whenever anything happens, there's going to be energy involved, and we can explain it in terms of an energy store. So an energy store is how energy is linked to an object. So there are 5 energy stores which we talk about when it comes to energy. And the first one, we're going to use an example to help us understand it. So I want to imagine that you take some water. You put it in a glass and you leave it out for an hour, sitting on your kitchen table, and its temperature is 20 degrees Celsius because it's been sitting out for an hour at room temperature. You take that water, you put it in a pan, and you heat it up. You didn't add any water to it. You didn't add or take away water, but what you have done is you've heated it up. So now you've got water at 50 degrees Celsius. So you've heated the water up. So what has happened here is that we have added energy to the water. We didn't add any extra water or take water away. We simply heated it up. We can explain the energy in terms of what we call the thermal energy store. We can represent the thermal energy store using a box like this. And when it was at 20 degrees, there was only a small amount of energy in the thermal energy store. Now, there wasn't no energy there because it's still at 20 degrees. It could have been less. It could have been at 10 degrees or 0 degrees. That would be even less energy. But it is at 20 degrees, so it's got some energy there. And when we took it and we heated it up, what happens is we think of adding energy to the thermal energy store. So now the object has more energy in its thermal energy store. So we have added energy to that store. So this is the first energy store. And we talk about the thermal energy store when there has been a change in temperature. So the water has gone from 20 degrees to 50 degrees. We say energy is added to the thermal energy store. Let's look at another energy store. So in this example, imagine a car. We've got a car and the car is going slowly. The driver decides they want to get to their destination more quickly. So they put the foot on the accelerator pedal. And what happens is the car changes speed. It's now going fast. So something has happened. So energy must be involved. And we talk about an energy store again. So we say energy has moved into an energy store, but it's not the thermal energy store because that's to do with change in temperature. Now the car might change temperature, but that's not going to make it go faster. We talk about this store called the kinetic energy store. The word kinetic means movement. So the kinetic energy store. Now again, when the car is going slow, it still has some energy in its kinetic store because it's still moving. It's going slow, but it is moving. And when we speed up, when we put the accelerator down, we add more energy to the kinetic energy store. So now it has more energy, it's kinetic energy store. So it's the same idea, it's another energy store, but it's to do with movement. So that's the kinetic energy store. Number 3. So imagine we have a table, and on the table, we have a book. We take the book, and beside the table, there is a wall with a bookshelf. We take our book and we put it in its right place up on the shelf. And what we've done here is we have lifted up the book. So we have changed its height. We have lifted it up. Now again, we talk about an energy store. We describe this using an energy store. But the energy store we talk about is the gravitational energy store. Gravitational energy store. And when it's on the table, there's only a small amount of energy here. Now again, it's not empty because the book is on the table. It's been lifted off the ground already to be put on the table. So it's got some energy in its gravitational energy store. When we lifted it up, we had to add more energy to the gravitational energy store. So the box now has more energy. So the 3 energy stores we've discussed so far, just to recap, are the thermal energy store, which is when we have a change in temperature. The kinetic energy store, which is when we change the motion of an object. So we make it go from not moving to moving, or we make it go from slow to fast, or we change from fast to slow, or we change from slow to not moving. So all of those are changes in movement. And then we have the gravitational energy store, which is to do with objects being lifted up or dropped down. We have the gravitational energy store. At this stage, what we're going to do is we're going to start doing a little mind map. So what we're going to do is I'm going to show you, I'm going to start it off here. We've got energy stores. And what I would like you to do is we're going to take 3 arrows out like this. And we're going to talk about, I'm going to show you how to do the first one. Okay. So we're going to talk about the thermal energy store. What I want you to do is tell me what that is. It should start like this: energy involved with with a change in temperature. Energy involved with a change in temperature. So I want you to tell me the name of the store, and I want you to tell me what that means, what it is. And if you can, for bonus points as such, tell me an example heating water. Tell me an example of when you might see this energy store. All right, so pause the video and copy down the one I have, and then I want you to do the other 2 we've learned so far. Okay, so you should only be watching and listening to my voice if you have finished that. So this is what you should have. Let's compare yours to mine. Here we go. Sorry, I haven't got an example done here. So this one, I've done this one already. This is heating water. For kinetic energy store, there's lots of examples we could have. Kicking a ball, driving a car. Anytime something starts to move or changes its motion, we're going to have an example of kinetic energy store. And then moving a book from a table to a shelf. I'm sure you could think of some other ones. Okay. I'm going to talk about 2 more energy stores now. Okay, so the next example that I have for you is I want you to imagine a battery. So we've got a battery. And our battery is new. It's what we call a full battery. It's a full battery. And you put your battery in your torch and you're going to use the battery. And after you've used it for a couple of hours, it's now a dead battery. We call it dead battery or a flat battery. It's dead or it's flat. With a battery, we talk about something called the chemical energy store, which has just got to do with energy stored by chemical substances. So inside a battery, there are some chemical substances, and when they mix together, they can do chemical reactions and they can release energy. We talk about the chemical energy store. And in the full battery, the chemical energy store is absolutely full of energy. And then as you use it to power your torch. What happens is that the store empties. Now, where does it go? Well, that's a good question. We'll look at that in the next video. But know that the store is full when the battery is full, and it's empty when the battery is dead. So we talk about the chemical energy store. The chemical energy store is also important when we talk about things like food. We eat some foods for energy. For example, we have bread for our lunch. There's lots of different kinds of bread. Sometimes we have bread in the morning, we have toast, we have croissants, and we sometimes have like rolls, chicken fillet roll, for example, at lunchtime. And we eat bread, and then other things like bread, we've got pasta, rice, potatoes. All of these things belong to the family or the group of foods called carbohydrates. And the carbohydrates have a large amount of energy in the chemical energy store. That's why we eat them, for energy. So we eat them at times of the day when we need a lot of energy. We've also got foods like something like peppers, for example. Now, I really like peppers on like pizza or as part of a salad, but you don't eat them for energy. If you just went around eating peppers all day, that's not really going to be enough to give you the energy to go and play a football match or to work hard studying, thinking at school all day. You need your carbohydrates for energy. Now, you get other things from peppers like vitamins and minerals, but you wouldn't get very much energy. So we say that there would only be a very small amount of energy in the chemical energy store of peppers. We also talk about the chemical energy store for substances called fuels. And these are chemicals that we can burn and release energy. So things like coal and turf and gas and oil. These are chemicals that have a lot of energy in the chemical energy store. They're packed full of energy. So we use fuels like wood, coal, and oil and gas to heat our homes because they're chemicals that have energy stored up in our chemical energy store. And a lot of chemicals have energy stored in our chemical energy store, but fuels happen to be the type of chemical that have a lot of energy in the chemical energy store. So chemical energy store refers to batteries, foods, and fuels. The last energy store that we're really going to study in detail is, I'm going to give you an example. I want you to imagine that we've got an elastic band. This is an elastic band. And at the moment, it is loose. So it is a loose elastic band. What do I mean by loose? I mean, it hasn't been stretched. So you just take out a packet and leave it on the desk, and it's loose. And then take that elastic band and you pull both ends. And what we do is we make it stretched. Now again, something has happened to the elastic band. And like I told you in the beginning, anytime something happens, energy is involved. So we talk about an energy store here also. And the energy store we talk about is one called the elastic energy store. Elastic energy store. And when the elastic band here is loose, it's only got a small amount of energy in the in the elastic energy store. And when we stretch it, we add energy to the elastic energy store. So now it has more energy. And the more you stretch it, the more energy you would add to the elastic energy store. There are three more types of energy stores, which I'm just going to mention, but we're not going to study them in detail. Now, if you keep studying science later on, like if you do physics and chemistry for Leaving Cert, then you would hear a little bit more about these three stores. But I'm just going to briefly tell them to you and touch on where we might come across them, but we're not going to study them in detail. The three are the nuclear energy store. This has to do with the energy stored inside an atom. So when we look at what's inside an atom, probably be next year when we look at what's inside an atom, we will see that inside the atom there are different parts, and there is energy that's stored inside the atom. And it becomes relevant when we talk about things like nuclear bombs or generating electricity from nuclear energy sources. And that's when this becomes relevant. So actually quite a lot of energy stored inside an atom. Another energy store is the magnetic energy store. And this is the energy involved when magnets pull on other objects. So when something is attracted to a magnet or pushed away from a magnet, we say energy is involved with the magnetic energy store. And finally, we have a store called the electrostatic store. And this is the store of energy that causes charged particles to attract or push each other away. Okay, so again, we will see charged particles in a future video. That's why I don't really want to talk about them too much at the moment, because there's a lot of this stuff we haven't really come across, and there's not really any everyday examples of this yet. I suppose if anybody's ever rubbed a balloon off their head or off their jumper and charged it up and then tried to stick it to the wall, if you've ever done that, then you were dealing with energy. You were adding energy to the electrostatic store of the balloon. But you don't really need to know any more than that. We're just going to focus on the 5. Okay, so at this stage, I want you to pause the video and I want you to finish off your mind map. I want you to add the other, especially these two here. I want you to add these two, the chemical energy store and the elastic energy store. I want you to add those to the mind map now. So pause the video and add them to your mind map. All right, so this is what you should have. This is my finished mind map here. Okay, so again, you should only be watching if you've done this already. So you see here, we just have the same as what we had before. These 3 were done already, and I've just added in these 2. So the elastic store and the chemical energy store. So pause the video there and take a look at what I've written. Make sure yours is the same. Okay, so again, if you didn't have any of that stuff, you should add the detail in a red pen now. And now it's time to do some practice. Okay, so what I have for you here is I have 9 pictures. And what I want you guys to do is I want you to tell me which energy stores are involved with each picture. Now, there's a couple of things I want to point out. This one down here, this is a chocolate bar. Sometimes students don't really understand what the picture is. It's maybe not a good picture. This here is what we call a pogo stick. I don't know if you've ever heard of a pogo stick, but it's like a toy that you bounce on. It's got a spring on the bottom. You bounce up and down on it. You may have seen it before. This is a radiator. Now, what's important, actually, one more thing before we go pause in the video there, what's really important to think about as well is that most objects have more than one energy store. So nearly every object will have more than one energy store. We only talk about one at a time because it's easier to just study one at a time. But if we take the example here here is a person. And at the moment, he is not moving. He decides he's going to go for a jog. Okay, so he's going for a little run. So now he's running. Obviously, something is happening, energy is involved. So which store do you think is involved here? On 3, I want you to speak your answer to the screen. 1, 2, 3. I'm hoping you said the kinetic energy store is involved. So the kinetic store. In the beginning, there is no energy in the kinetic store. He's not moving. And there might be a very small amount because he's like still blinking. He's still breathing. Still going to be some little bits of movement. But when he's running, he's added a lot more energy to the kinetic store. But hopefully you can appreciate, and any of you who have been for a jog before will know, if you stay running for maybe 10 minutes, another store is going to be involved as well, the thermal energy store. Because as the person runs, they are going to heat up. They are going to warm up. So when they're just standing around doing nothing, they're not sweating, they're not feeling hot. But as they run for like 10, 15 minutes, they will start to feel much warmer. Their temperature of their body will increase. They will start to sweat. They will start to breathe heavier and try and cool themselves down. That is the thermal energy store. So as you can see, most things when they happen involve more than one energy store. But here I would say that the main one involved is the kinetic energy store. This is like a secondary energy store. This is like secondary. It's not the main one. So it's like it's a side story, if you like. Now it's still there, it's still happening, but it's not the main show. Okay, the main show is the kinetic store. Now what I want you to do in these pictures is I want you to list all the ones you can, but circle. Sorry, I've lost the pictures. Where have they gone? Oh, yeah. But circle what you think are the main ones. Okay, so list all the ones you can and circle what you think are the main ones. Pause the video and do that now. Okay, so the first picture is a car, a racing car, and it's moving. Okay, if that wasn't clear, sorry. If that wasn't clear, the line showed that the racing car is moving. Okay, what stores are involved here? Okay, you should be talking about the kinetic energy store. Kinetic is the main show. So you should have kinetic and circle that one. But also, some of you may have realized that as the car drives, it's going to get hot. It's going to warm up. Most cars, the engine gets hot. As they drive, especially a racing car, which will drive very fast. So the thermal energy store would be another one. And also it's got fuel. So we would say that the chemical energy store is involved, the chemical energy store of the fuel. So well done if you had those. If not, add them in, but do keep a circle around kinetic. Right, the second one, the slingshot, the elastic energy store is the main one because we stretch the rubber bands. And then as you fire the stone or whatever you've got in it, you're going to have the kinetic energy store. The main story there is, or the main energy store is going to be the elastic. The third one with the parachute here, the main one is going to be the gravitational energy store. Gravitational energy store, because a parachute person starts up high. So they've got a lot of energy in the gravitational energy store. Now, as they fall down, they're going to have energy. We're going to be talking about the kinetic energy store and possibly the elastic energy store of the strings as they might stretch a little bit. But the main story again there is the gravitational. So make sure you have that circled. The next one, I suppose it's got two main ones, I would say. The thermal energy store, obviously, because it's a fire, it's going to get hot. But also the chemical energy store in the wood, because it won't burn. The fire won't burn without the chemical energy store in the wood. If you try and light fire to a rock, it's not going to catch fire because it's not a fuel. It doesn't have a lot of energy in its chemical energy store. So that's why wood burns well, because it's got a lot of energy in its chemical energy store. So both of those I would think are energy stores involved there, kinetic and thermal. The fourth one, rubbing your hands together when you feel cold. So you rub your hands together to make them warmer. Obviously, we're talking about the kinetic energy store as you move your hands. But you also have the thermal energy store, which is the change in temperature in your hands as you rub them together. So we all have done that on a cold morning to try and warm up our hands. The next one is Tigger on a pogo stick. So it's a toy, obviously, and he's going to be bouncing up and down. Now, when he bounces up and down, I suppose this one I should have explained a little bit better. He's got a spring, and the spring is going to be compressed or squashed. So the energy store involved in that is the elastic store. I really probably should have explained that one better. That a spring, when you stretch an elastic band, that is the elastic energy store. But also when you have a spring and you compress it, you squash it together, that is the elastic energy store as well. So either stretching or squeezing, compressing something, both of those would involve the elastic energy store. So the spring, the elastic energy store is the main one there. But Tigger's also bouncing up and down. So he's going to have kinetic, and we're going to be talking about the kinetic energy store, and we're going to be talking about the gravitational energy store as he moves up and down. The main one is the elastic energy store of the spring. The next one is the radiator, and the main thing there is the thermal energy store. So I'm hoping, yeah, thermal energy store. And notice that I've never mentioned anything about an electrical energy store. So even though that radiator is plugged in, there's no such thing as an electric energy store. So if you wrote that, that is wrong, okay? And we'll see a bit more in the next video why that's wrong. But we're talking about the thermal energy store. The chocolate bar is food, so it's the chemical energy store we're most interested in there. And the rocket Well, the rocket has quite a lot going on. First of all, it's got fuel. It's got a burn, chemical energy store. It's got a big flame coming out the back. So we're going to be talking about the thermal energy store as it heats up everything around it. We're going to be talking about the gravitational energy store as the rocket lifts off the ground. And we're going to be talking about the kinetic energy store as the rocket begins to move. I would guess that the kinetic energy store is the main one there, but that one's a little bit, as you can see, there's a hell of a lot going on with that rocket. Right, the next thing I want you to do, last question, is I want you to pause the video in a minute, and for each of the 5 main energy stores, I want you to write down 2 objects which are involved with these stores. Now, you can use any examples, but 2 objects which should be involved in these stores. Pause the video and do that now. Okay, so show me listening if you have done that, and this is the kind of thing that you should have said. For example, the thermal energy store, you have things like a cup of coffee or a bowl of porridge. So when the coffee is fresh and you've just poured it, it's got a lot of energy in the thermal energy store. And if you left it and forgot about it for half an hour, you're like, oh, damn, I forgot to drink my coffee. This happens to me all the time. If you do that and you go to drink it after like 30 minutes, then your coffee's going to be cold and not very nice. And it's obviously got less energy in its thermal energy store then. It's the same with the porridge. Goldilocks and the 3 bears. Daddy Bear's porridge had the highest amount of energy in the thermal energy store. It was too hot for Goldilocks. Baby Bear's was just right, if you remember, and it had the lowest amount of energy in the thermal energy store. Kinetic, then, you can think about things like a ball, kicking a ball, a moving car, or an aeroplane. Gravitational, we can also talk about aeroplanes because they're in the air. You can talk about a ball when you throw it up in the air. You could talk about, you know, what else? Anything that's going to fall down, basically. So a bottle rocket or an apple falling from a tree, all of those things. The chemical energy store and the elastic energy store, for chemical, you could talk about foods, batteries, and fuels. And elastic energy, you're really talking about elastic bands and springs. That's the main thing you're going to be talking about. Stretching an elastic band or stretching or compressing a spring. All right, well done, guys. If you found this video helpful, I would appreciate if you could give the video a like. It might help other students to find it, and it might help other people. Okay, so quick recap. This is a good way to recap when you need to. If you want to look over your energy stores again, you now have this nice little mind map to help you very quickly revise it. So the 5 energy stores: elastic energy store, chemical energy store, thermal energy store, kinetic energy store, and gravitational energy store. Just as an aside, can you remember the other 3, just the names? We should probably stick those in. So can you remember the 3 names? All right, so pause the video and try and write down the 3 extra ones that we talked about. Okay, hopefully you were able to have a go at that. If not, this is them. We have the nuclear energy store. We have the magnetic energy store. And then the hardest one to remember, I think, is the electrostatic energy store. Now notice, every time I say kinetic, and I always follow it with energy store. That's important. You don't really just want to drop it and just talk about kinetic. You want to say kinetic energy store. So I purposely do that every time because it's important. All right, that's it, guys. I will see you in the next video when we will be talking about something called energy transfers. Okay, so it's still related to this, and it's important that we understand this stuff before we go on to that. So I look forward to seeing you in the next video.